You know, it's funny. We often think our most advanced technology is something brand new. But here's what most people don't realize. A lot of the time, we're just playing catch-up with the natural world. And it turns out, that's not an accident. It's actually a deliberate strategy, one that's quietly unlocking our future.
Okay, take this for example. A few years back, scientists unveiled this incredible stealth sheet. It's thinner than a credit card, but it can make a person basically invisible to heat-seeking cameras. It absorbs almost all the infrared light that hits it, effectively erasing your heat signature. It could even fake a heat signal somewhere else to throw cameras off the trail.
I mean, that sounds like something straight out of a spy movie, right? A true glimpse into the future of technology. But what if I told you the big idea behind it isn't new at all? What if the blueprint for this kind of thinking was actually written down decades ago and then, for the most part, forgotten?
Well, the real story starts right here. This is a declassified NASA technical report from 1991. Now, the title is a mouthful: Engineering Derivatives from Biological Systems for Advanced Aerospace Applications. Doesn't exactly scream page-turner, but trust me, inside this document is a revolutionary way of thinking that's more important today than ever before.
So let's go ahead and open up this time capsule. We're about to see how NASA, more than 30 years ago, was trying to systematically decode nature's most high-tech secrets. This one sentence from the report says it all. The engineers at NASA understood a really powerful truth. Nature is the greatest R&D lab in the universe. It's had a budget of billions of years to run endless experiments. So why on earth would you start from a blank page when evolution has already perfected the design?
And let's be clear, this wasn't just a casual interest for them. The whole point of this study was to build a formal, repeatable playbook, a step-by-step guide for finding nature's best solutions and adapting them for incredibly complex aerospace problems.
So what did they actually find? Well, let's dive into some of the mind-blowing examples they put together. This is where things get really, really interesting. Just look at this comparison of sensory systems. A moth can detect a single molecule of a chemical from miles away. A pit viper's ability to sense infrared heat is so sensitive, it makes the best man-made detectors from that time look like children's toys. It just goes to show how far we still have to go to even come close to nature's engineering.
And here's how they started putting that idea to work. The report is basically a huge list of problems and nature's solutions. How do you stop astronauts from losing bone mass in zero gravity? You study hibernating bears. Need a more accurate speed sensor for a jet? Take a look at how a beetle sees the world. Annoying glare on an instrument panel? Believe it or not, a moth's eye holds the answer. Let's just pause on that bear example, because it's absolutely wild. Astronauts suffer from serious bone and muscle decay in space, but a bear can lie still for months on end and emerge with its skeleton pretty much intact. For NASA, this was a potential goldmine. They figured if they could understand the biology, they could maybe develop a way to protect astronauts on those long missions to Mars and beyond.
And look, this wasn't just a bunch of cool ideas on paper. The report shows how these natural blueprints were already being translated directly into real-world engineering and design.
I mean, we all see this simple stuff, right? The swept-back wings on a bird look like the wings on a jet. But this report went so much deeper. It talks about how the microscopic texture of a shark's skin, which has these tiny little grooves called riblets, can dramatically reduce drag in the water. This wasn't just saying, hey, that looks similar. This was a full-on scientific breakdown connecting these biological tricks directly to building better, more efficient aircraft.
And get this for a real-world win. Some of that NASA research on shark skin was used to create a special coating for the hull of the Stars and Stripes yacht. And that yacht went on to win the America's Cup back in 1987. That is a direct line from the skin of a shark to a World Championship trophy. How cool is that? So, you might be asking, why does a 30-year-old report matter so much right now? Well, because this wasn't just a collection of neat tricks. It was documenting a massive paradigm shift in how we approach innovation itself. This shift actually has a name: bionics. It's the science of looking at living systems, understanding the principles that make them work so well, and then applying those same principles to build our own technology. It's the realization that biology and engineering are really just two sides of the very same coin.
And this is the hidden truth, the real legacy of this old report. It was never about just copying nature, just slapping wings on a machine because birds have them. It was about creating a formal, repeatable process to observe, to understand, and then to translate nature's deepest principles into brand new technology.
And that brings us right back to where we started. That high-tech stealth sheet?
Its amazing surface is basically a super advanced version of the light-trapping structures found in the eyes of a moth, a topic explicitly covered in that 1991 report. The ideas laid out in this dusty old document are the direct intellectual ancestors to today's biggest breakthroughs in robotics, smart materials, and even AI.
So, it leaves you with one final thought. For almost 4 billion years, nature has been running the most complex and successful research and development project in the history of the universe. The library of perfected solutions is practically infinite. The only question left is, which blueprint will we decide to unlock next?
Don't go anywhere, hit subscribe, and we continue.
You know, when we think of an electric grid, we picture this massive, sprawling marvel of human engineering, right? Miles of wires, giant power plants. But what if I told you that nature built its own electric grid billions of years ago? Here's what most people don't realize. There's a hidden world where living organisms don't just use energy, they are the power grid, operating on a scale so tiny it's almost impossible to imagine.
And that brings us to a question that sounds like it was pulled straight from a sci-fi novel. Could a living, breathing organism actually conduct electricity just like a copper wire? I mean, the whole idea seems to completely break the fundamental rules of biology. But the answer isn't just yes, it's a discovery that's forcing us to rewrite everything we thought we knew.
All right, so let's get into it. The story really kicks off with an idea so radical, so out there, that the scientific community, well, they pretty much laughed it out of the room. I mean, listen to this. This quote from a top researcher at the US Naval Research Laboratory says it all. The scientific community didn't just disagree with the idea, they flat out rejected it. The concept of a living wire was seen as, a basic misunderstanding of biology, a flawed theory that was basically dead on arrival. But here's the thing. In the face of all that doubt, the researcher behind this wild claim, a guy named Derek Lovely, he just didn't back down. He and his team kept pushing forward, absolutely convinced they were on the verge of something revolutionary.
So, what was this unbelievable claim that had everyone so worked up? And how could it possibly work? This is where we get to unpack the absolutely brilliant science behind it all. To understand this, we need to look at something called a microbial fuel cell, or an MFC for short. The easiest way to think about it is like a tiny biological power plant in a box. It's a whole system designed to tap into the natural electrical potential of microorganisms, turning simple organic waste directly into electricity.
So how do these little power plants actually work? It's a beautifully simple three-step process. First, the bacteria do what bacteria do best. They eat. They just munch on organic waste. Then, as they digest that waste, they release electrons. And this is the magic part. The bacteria literally grow their own nanowires to shuttle those electrons over to a collector, which is called an anode. And that creates a steady flow of electricity.
And this is the hidden truth that changes everything. The wires aren't some external thing that we add to the system. The bacteria build them themselves. They're these incredible protein filaments, self-assembled into what scientists now call bacterial nanowires. They are literally nature's own power lines, forming a living, breathing electrical grid on a microscopic scale. So we have bacteria that can build their very own electrical grid. I mean, that's a mind-bending discovery all on its own. But the real question is, what can we actually do with it? Well, this is where science fiction starts to become science fact.
The potential applications here are just staggering. Seriously, we're talking about everything from cleaning up radioactive waste and desalinating seawater to creating living sensors that can detect pollutants and even powering autonomous robots. This isn't just some neat lab curiosity. It's a platform for a whole new kind of technology. Let's take one of our most dangerous environmental problems, nuclear waste. Scientists have found that a specific type of bacteria called Geobacter uses its nanowires to change the very chemical state of uranium in contaminated groundwater. It literally breathes out electrons onto the uranium, locking it into a solid mineral form so it can't poison the water supply anymore. It's like a microscopic, self-replicating cleanup crew for nuclear contamination. And then you have the world of robotics. Researchers have actually built these things called ecobots that run entirely on microbial fuel cells. These robots literally feed on waste, things like rotting food, sugar, even dead insects, to power themselves. It's the ultimate in sustainable autonomous tech. Now, this all sounds
absolutely incredible, right? But it's also important to get a clear picture of where the technology is today and, the challenges that it still needs to overcome before it can really power our world. So let's do a quick reality check. The power output right now is still very low. We're talking about 17 microamps per square centimeter. To put that in perspective, that's thousands of times less power than what your phone charger puts out. So while it's fantastic for tiny, low-power sensors in remote places, you're not going to be plugging your laptop into a pile of mud anytime soon. So the road ahead has a few key hurdles. Number one, of course, is boosting that power output. But scientists also have to figure out how to bring down the cost of the materials, how to scale these things up from a tiny device in a lab to something that works on an industrial scale, and they need to improve the efficiency of some of the internal parts, like the special membrane that keeps all the chemical reactions in balance. But even with those challenges, the forward momentum here is undeniable. So what does the future of this bioelectric technology really look like? This comparison right here really gets to the core of why this is all so revolutionary. Think about it. Traditional batteries are built on a model of extraction and disposal. We mine heavy metals, we use them, and then they become toxic e-waste. Microbial fuel cells, they represent a completely different way of thinking. It's a cyclical, regenerative model where your fuel is literally waste and the device itself is biodegradable. It's not just a new type of battery, it's a whole new philosophy of energy. And this idea just blows my mind, because these systems can just run on whatever organic stuff is around them, like the sediment at the bottom of a river. They could, in theory, power a remote sensor forever. No battery changes, no maintenance, just a continuous, living power source. So one idea that was once just dismissed as impossible is now paving the way for self-powering robots and sensors that could literally last forever. It's a pretty powerful reminder that some of the biggest breakthroughs are hiding in the places we've completely overlooked. It really makes you wonder, what other secrets are hiding down there in the microscopic world, just waiting to completely change our future?
Don't go anywhere, hit subscribe and we continue.
Take a look around any modern city. What do you see? Concrete, steel, glass, everywhere. For more than a century, that's been our go-to blueprint for building the world. But here's what most people don't realize. That entire blueprint might be fundamentally flawed. What if the future of our cities isn't something we mine from the earth, but something we grow from it?
It sounds like something straight out of science fiction, doesn't it? A skyscraper that literally breathes, a bridge that gets stronger the older it gets. But this idea, this radical reimagining of architecture, it's not some futuristic fantasy. In fact, it has roots that stretch back for centuries.
To understand this, you have to see just how different this approach is. Our current materials, we have to mine them, process them, assemble them. It's this hugely energy-intensive process with a massive carbon footprint. And the final product is static. It's brittle. Living materials, on the other hand, well, they start from a seed. They're adaptive, they're flexible, and instead of pumping carbon into the atmosphere, they pull it out. It completely inverts the entire logic of how we build.
So where did such an incredible idea come from? Well, you might be surprised. It wasn't born in some high-tech lab. It began with an ancient partnership, a collaboration between humans and the natural world itself.
Deep in the forests of Meghalaya, India, the Warkhasis people have been practicing this unique form of engineering for generations. They don't build bridges with tools and machines. No, they guide them into existence, patiently, carefully, working with the amazing aerial roots of the Ficus elastica tree. This isn't just a concept, it's a proven, living technology that has lasted for centuries.
And the process itself, it's really a masterclass in patience. It starts with gently guiding these young, pliable roots across a river, sometimes protecting them inside hollowed-out branches. Then, over years, those roots are woven together. After a decade, maybe 15 years, those thin little tendrils fuse and thicken, maturing into an unbelievably strong and resilient structure. We're talking about a bridge that can span 50 meters and withstand the most powerful monsoon floods. Just incredible.
Okay, so if this is what's possible using ancient techniques and pure patience, what happens when we bring modern engineering into the picture? Well, that question leads us to this incredible new field called biobotanic.
Biobotanic. It's a German word that basically translates to living construction, and it takes that core principle of guiding growth and it systematizes it. This was pioneered by architects and engineers who use these temporary metal frameworks to train young, really fast-growing trees, like willows, into very specific architectural shape.
So here's how it works. The process starts by planting these young willow saplings in tight bundles, and their growth is directed by a steel scaffold. Now at first, that metal scaffold is doing all the work, bearing all the weight. But over time, the trees grow. Their trunks actually merge and thicken, grafting together until they become the primary load-bearing structure. And this is the magic part. Eventually, that metal support can be removed completely, leaving behind a living, breathing bridge that is holding itself up. And this is where things get really mind-bending. Because this technique opens up a world of possibilities. We can start to move beyond just a single bridge or a small tower. We can start to think about an entire city as a living, breathing organism. This is the incredible vision of pioneers like architect Phil Ayres. Think about it. For so long, our cities have been designed as these sterile, concrete environments, pushing nature out to the edges. But biohybrid architecture, it invites nature back in. And not just as pretty decoration, but as a functional, integral part of the city's fabric. It's about designing a space that benefits more than just us humans. The potential benefits here are just staggering. I mean, imagine a building facade that scrubs pollution from the air, or an apartment complex that filters its own water. What about a structure that can literally heal itself when it gets damaged? These wouldn't be just buildings anymore, they'd be active ecosystems, boosting biodiversity, pulling carbon from the atmosphere, and creating a truly circular economy. It's a total game changer. So you see, this is about so much more than a new construction method. This is a fundamental change in our entire relationship with the natural world. It's a shift from a mindset of imposition to one of genuine collaboration. All of this leaves us with a really fascinating question to ponder. As we design the smarter, more resilient cities of tomorrow, maybe our most important tool won't be a crane or a welder. Maybe it'll be a watering can. Perhaps the future isn't something we build, but something we grow together.
Thanks for watching. Support BioVellum by liking, subscribing, and sharing. Let's explore the secrets of nature together.